Hello, namaste, Sat Shri Akal, Assalamu alaikum. Hope you are staying fine, healthy, and strong. It's good to be back again. I hope you liked the first video, and thank you once again. First of all, secondly, the last time the video which was uploaded, I tried to explain as much as possible, and then like the last part that we could cover up was the classification of algebraic expression, that was monomials, binomial, trinomial, and polynomials. So moving on next. Today I'll be trying to hit on the chapters. Maybe it might not be possible for me to solve all the sums together, but I'll try as much as possible to pick up sums from all the topics and try to solve. So today the first topic the first thing that I have started is from that is unit 9.1. That is simplifying algebraic expression. What do you mean by simplifying? Simplifying means like trying to make it as simple as possible. As you can see here, simplifying algebraic expression to make an algebraic expression understandable and solvable. And just above that you can see there are two laws of exponents which I have written down here. That is x to the power a into x to the power b gives us x to the power a plus b. The second one, as you can see here, x to the power a divided by x to the power b gives us x to the power a minus b. Both these two are a part of the laws of exponents. So why I have written those two down is that by using those two, we'll try to solve these four sums, which has been taken out from 9.1, that is question number 1 and question number 2. So as you can see here, the first question we have y raised to the power 2 into y raised to the power 4. So in order to solve, let's try to follow the first law of exponent, that is, as you can see on the top, that is x to the power a into x to the power b gives us x a plus b. When we have the sign as a product, we can see that the power gets added together, and when we have the sign as division, we can see that power gets subtracted subsequently. So in order to solve the first, let's begin with, we have your y squared into y to the power 4. So how do we do it? First we can see here, both are common. So I can take your y, since it's a product, since multiplication is here, so what we can do is we simply have to add the powers. That's very simple. Always remember, when product is there, we add, and then when division is there, we subtract. It's a very simple thing. Y raised to the power 2 plus 4 gives us y. 2 plus 4 gives us 6. That's it. That's simple and it's understandable. As the definition or as the expression says, making an algebraic expression understandable and solvable. Now, here we have done with the multiplication. Let's move on to the division. It's very simple. Since when we have divide, as I have told earlier, when division is here, the power gets subtracted. So b to the power 8 divided by b to the power 7 gives us b to the power 8 minus 7 gives us b to the power 1. It's not necessary that you have to put 1 because it's quite understandable. Nothing is there, that means it's 1. So moving on to the next one, that is, we can see here, we have 2m to the power 4 into 2m to the power 3. That is 2m to the power 4 into 2m cubed, if you can say. So what we can do here, let's try to separate the numbers together and let's try to bring the variables together. That is 2 into 2 into m to the power 4 into m cubed. Right? So 2 into 2 gives us 4. We have here m. Let's follow the first rule of exponent, that is x to the power a into x to the power b gives us x to the power a plus b. So here we have m, 4 into m cubed. That means since multiplication is there, since it's a product, so definitely we know that we have to add the powers together. That is 4 plus 3. 4m to the power 7. So now for unit 9.1, the last sum we have here, as we can see just now we have solved with the multiplication. Let's try to do with the division also. 15t to the power 7 divided by 5t cubed. So I hope you can see, right? This one. 15 divided by 5. 15, and then we have top here we have t to the power 7. Here we have t cubed. Right? 5 and 15 can be cancelled. So here we have 3 t to the power 7 minus 3. Since it's division, so definitely the powers get subtracted. 3 t to the power 4. That's all we have from 9.1. Okay, now moving on to the next, we have constructing algebraic expression. As you can see, I have written it down here. What actually do we mean by constructing algebraic expression or construction of algebraic expression? In an algebraic expression, we all know that letters represent unknown numbers. We often need to construct algebraic expression to solve our problems. Now, using this, one thing I want you to remember is that, like, definitely when we have this kind of quotients, reasoning kind of quotients, the first thing that you should remember every time is you have to read the quotient again and again, unless and until you think and you are confident enough that you can attempt the quotient. Because most of the time, what happens? Number of students, they make a mistake. The first reason being what is, like, they don't read the quotient. And the second thing is, though they read the quotient, they make a mistake because they don't reason, they don't think. That is the problem. That is where the problem starts. So now, as you can see, there is a quotient here. Xavier thinks of a number. He might be thinking of any number. Say, for example, like it's n. Xavier thinks of a number n. So we are asked to write an expression in terms of n for the number Xavier gets when he. See, there are a number of quotients in this quotient, but so I have just selected a couple of quotients. As you can see here, I have selected two quotients. Once again, let's rewind back and then let's try to read the quotient back. As I have said, it's very important that you read the quotient, and then it's very, very important that you try to understand the quotient before you hit the quotients. Now, Xavier thinks of a number n. We are asked to write an expression in terms of n for the number Xavier gets when he. Number 1, that is number E I have taken here. First, what we have to do is, let's read the quotient once. Multiplies the number by 2 and then adds 9. Right? What usually you guys do, what usually the students do is, they will just read the quotient once and then they will say they can't do it. It's okay, let's forget it, let's move on to the next question. No, it's very simple. If you can see, all you have to do is you have to read the quotient and try to understand it. So, multiplies the number. What is the number here? Since we do not know the number, as you can see here, it's an unknown number. Multiplies the number by 2. What is the number? The number here is given as n. We can assume any number. Since in this quotient they have given that as number, represented the number by n. It can be a, b, c, d, x, y, z, any number scheme. It may be any variable, any letters. Multiplies the number by 2, once again, and then adds 9. Multiplies, we all know multiplies the number. What is the number we have here? Number we have here is n. So multiplies the number n into 2. Multiplies the number by 2 and then adds 9. Simple. We get 2n plus 9. Right? So the next question here, add 12 to the number. It's very simple. Add 12 to the number. What is the number here? N. Add 12 plus 2. Is that very simple? Once again, I request all of you, the thing is that you have to read the quotient again and try to understand. You don't have to rush in. Try to read the quotient and try to construct an expression. That is very important. Next, we have question number 2, where we are asked to find the perimeter and then we are asked to find the area so that we can construct an expression. Okay, as you can see that from the figure itself, it's a rectangle, right? And then we have the length given here as 4x and then the breadth given here as 3y. So we are asked to write an expression for a perimeter, for its perimeter, and also for its area. Now, since we know it's a rectangle, we know the formula, which is very simple. That is 2 into bracket L plus B. We'll follow the formula, or else vice versa. You can directly add everything together, which will ultimately give you the answer. As you can see, even the whiteboard is in the shape of a rectangle. That means this becomes our length, and that becomes our breadth. Now, we have the length here as 4x, and then we have the breadth here as 3y. So we are asked to construct an expression, that is, we are asked to construct an algebraic expression using that. So perimeter, since we all know the formula, perimeter of rectangle is 2 bracket L plus B. 2. What is the length here? Length is denoted by 4x. We have the value of length as 4x, and then the value of B, breadth as 2y. Now, you can stop here also. It doesn't matter. That's also correct. But if you would like to again express it more, then you can expand it. 2 into 4 gives us 8x addition is here, plus 2 into 3 gives us 6y. So that is our perimeter. Now moving on to area. What is the area of a rectangle? Most of the time when I ask the students, sometimes it's very disheartening to know that they still don't know the formula. And then see, it's very simple, boys and girls. Always remember the formula for perimeter and area of rectangle, square, whatever the polygons are there. It's very important that you remember it. So the area of a rectangle formula, we all know, that is length into breadth. What is the length here? We have 4x. What is the breadth? We have 3y. The numbers we have here is 4 and 3. That is 4 into 3 gives us 12. X into y gives us x. Okay. Moving on to the next, we have substituting into expressions. Substituting generally means like to substitute a value. Here we have the quotient, that is question number 1, where the value of a is given as -2, b is given as 3, c as -4, and d as 6. There are maybe around 6 or 7 questions, but I have taken only one. Whereas in my notes I have done I have solved 2 more sums here. So I'll be doing only one sum here. So we have here question number H, that is d square plus ab. So firstly, what we have to see, the value of d. What is the value of d? As we can see, it's given as 6. That is 6 square plus the value of a is given as -2, and then the value of b is given as 3. Since minus is there, so it's better we keep into brackets. So 6 square, the value of 6 square we know it's 36. Plus no minus gives us minus. 2 into 3 gives us 6. So 36 minus 6, that is 6 subtracted from 36 gives us 30. Now next question number 2. Even from question number 2 I've taken only one sum. The values are given. W equals to 5, x equals to 2, y equals to -8, z equals to -1. All we have to do is we have to substitute the value of x and z. As you can see in the question, x cubed minus z squared. That means we have to substitute the value of x and z. That is 2 bracket x. We can see the value of x here, it's given as 2. That is cube. Minus z. We can see the value of z is given as -1 cube. -1 square. Now, as we know, when we follow the rule of Bidmas, what is there inside the bracket, we try to solve it first, simplify it first. So here we have here 2 bracket 2 cube. 2 cube we can write it as 2 into 2 into 2. That is 8. Minus of -1 square. You know -1 square is -1 to -1. Negative into negative will gives us positive. That is plus 1. That is 1 square. That is 1. So here we have 2 into 8 minus 1 gives us 7. So we get the value as 14. Once again, let's go for a quick review. 2x cubed minus z square. 2. The value of x is given as 2 here. 2 to power 3 minus of z -1 square. 2 cubed gives us 8. Minus remains the same. Here -1 into -1, that is -1 square can be written as -1 into -1 gives us 1. 8 minus 1, that is 2 into 7 gives us 14. Now we will be moving on to the next, that is deriving and using formulae. On moving on to deriving and using formulae, I've already given in the notes, so I'll be just doing 1 or 2 sums only. So basically, use the formula, that is F equals to MA, to work out the value of value of, let me just take number B. F when m equals to 26 and a equals to minus 3. When m is 26 and a equals to minus 3. So here what we have to do, they have already given us the formula. We have to use this formula and find the value. We have to work out the value. So given F equals to ma. As you can see, like in the previous topic, that was like substituting the value. The same way here also, what we can do is the value of m is given and the value of a is given. So when we have to put these values together and then find the formula for F, that is force equal to mass into acceleration. There is m 26 into a is given as minus 3. So when we multiply these two together, 3 into 6, 18, 2 to 6, 78. Minus is there? Minus. Okay. The same way, let's work out for question number 3. That is, here we have to use the formula V equals to u plus 80, where v is the velocity, final velocity, uniform velocity, plus acceleration into time. We have to use this formula and work out the value of, okay, see, u when v equals to 75, a equals to 4, t equals to 12. Okay, when v equals to 75, a equals to 4, t equals to 12. Now we have to use this formula and then we have to find out the value. But you can see here we are asked to find the value of u. That means the subject here is u. So given v equals to u plus 80, I would so what we can do here is that we have to change the subject. What we can do is we have to change the subject. When you turn on to the page, like the page that is 89, deriving and using formula, you can see on the right side corner top, you will see that there are these formulas which have been segregated as per the change of subject. You can see here v is a subject, here u is a subject. So when u is a subject, what we can do, we have to rearrange the formula. That is u equals to v minus 80. Now we can substitute the value, that is v. What is v? The value of v is given as 75 minus what is the value of a? Value of a is 4 into the value of t is 12, right? 75. 4 times 12 gives us 48. So here we have 75 minus 48. 15 minus 7. 15 minus 7 we get as how much? 15 minus 8 we get as 7. 6 minus 4 we get as 2. V equals to 75 minus 4 into 12, that is 75 minus 12, 4 is 48. 75 minus 48, 15 minus 8 gives us 7. 6 minus 4 gives us 2. That is the value we get as 27. Okay. Now we will move on to the next one, that is factorizing. Factorizing. What do we actually mean by factorizing? Factorizing actually means like we usually take out the common factors and we try to solve it, and that's how we are going to do in 9.5. That is, from 9.5, number 1, I'll be taking one sum, number 2, one more sum, one sums I'll be solving it, so it will be easier for you to also understand. And then if you have any doubt, you can refer back to the notes which had been given to you, so where it has been explained more detailedly. Number 1, I'll be doing number B. From 1, I'll be doing B. That is 10y minus 15 equals to 5, 2y minus box. Now, when we see here, as I said earlier, factorizing means like we usually take out the common factors and then we try to simplify it as much as possible. So as you can see, the quotient here is 10y minus 15, and as you can see, partially half part of the sum has been done, that is 5 bracket 2y minus box. So we are actually asked to find out the value of the box, which we do not know. But when we look into the quotient, we can see it's very clear to us that 10 and 15 are factors of 5. So 5 becomes a common factor here. So 5 we can take it out, right? And when 5 is being taken out from 10, if I take out 5, 5 into 2 gives us 10y. Here we have subtract. Now 5, it's very simple now. 5, 3 times gives us 15. So in case, like if you have a doubt there, if you doubt this, all you can do is once again 5, 2y minus 3. Now remove the bracket. Now remember, when we remove the bracket, it means like we are expanding the expression. So when we expand the expression, that means we have to remove the brackets as well. So here we can see 5 into 2, we get 10y minus 5 into 3, 15. So which gives us the answer, vice versa. It's either or. If you have a doubt in the solution, use the solution and then convert into the quotient. Now, second way, in the second question, I have done one sum from question number 1. Simultaneously, I'll be doing one for question number 2. From question number 2, let me do, there is B, 3y minus 18. Okay, it's very simple here again, just the same way as we have solved for question number 1, 3y minus 18. As we can see, 3 and 18 are both the multiples of 3, right? So what I can do is I can take the common factor, that is 3 here, and if I take 3 out, so what remains here is the variable y minus of 3 into 6 gives us 18. That's very simple. Now you can, like as I said earlier, if you doubt, you have to solve this one and make sure that you get the quotient as your answer. That's it. Okay, from number 3, let me do one more sum. 6y squared minus 12y. It's all the same. It's very simple. Once you get to know how to do one sum, it becomes like, you know, like it's just in your fingertips only. 6y squared minus 12y. Okay, so we can see here 6 and 12 are both the multiples of 6, right? Yes or no? Yes. And then we see there, as we know, factorizing means like taking off the common factors. Here we have common is 6, and then we can see we have the common variable y. Now, if from 6y squared, 6y is taken out, that means 1y remains alone, minus. Here we can see 6 and 12. 12 is a multiple of 6, right? Yes or no? So 6 2 times gives us 12. And remember, y is already been taken out. So our answer remains 6y bracket y minus 2. Thank you. Now moving on to the next. We have fractions, addition and subtraction of fraction. It's very simple. The only thing is that while in algebraic expression we have to deal with the variables, or while in the algebraic expression we deal with the variables, and when we do a simple fraction we deal with numbers. So even for these fractions, I I don't need much to explain you because which you also know. So I'll be solving just a few sums from here. That is, say from fractions number 1, b. I'll do b. That is x by 7 plus 3x by 7. We can see, remember, whenever the denominator is same, it's very simple. Whenever the denominator is same, here we can see that the denominator both are same. That is 7. 7 1 times gives us 7. 7 1 times gives us 7. 1 into x gives us x. Addition, same. 7 1 time gives us 7. 1 into 3x gives us 3x. So the value is 4x by 7. Now, question number 2. In question number 2, as you can see, there are 6 sums. So let me do number C. That is 5c by 7 minus 2c by 5 gives us, okay, since in the question, in the textbook they have given the sums like where the boxes are given, right? So what we can do here is, rather than just straight away writing the answer, I would request you and I would recommend you try to solve it in the rough column and then try to figure out the answer. So what I can do here is, usually we find the LCM of that is 7 and 5, that is 35. Right. 7 and 5, the LCM we get it as 35. So let's go to that. Let's go in the traditional way, because like it's when you go in the traditional way, it becomes more simple to understand, easier to understand also. 7 5 times gives us 35. 7 5 times gives us 35. 5 times gives us 25c. Minus of 5 7 times gives us 35. 7 2 times gives us 14. So when we subtract 25 minus 14, 5 minus 4 I get 1. 2 minus 1 I get 1. That is 11c by 35. Now when you look in the textbook, they have segregated, they have separated each and everything. All you have to do, you don't have to get confused. If you want to follow the way they have done in the textbook, it's very simple. You can do like 25c by 35 minus 14c by 35. But the thing is that you have to redo it again, which I wanted to avoid. But since if you are comfortable with this, either or, you can do either way. You can either follow the traditional way or you can follow this method also. Both remains the same. Now, the most important part, and that is a last topic which we have now, that is expanding the product of two linear equations. From here, even from this, I'll just do one sum. Question number 1 is simple because it's in the form of fill in the blanks, which I'll be doing question number 2, which will give you a better understanding to how to find. That is from question number 2. Let me do, say, number B. X plus 1, x plus 10. So when we talk about expanding, that means we have to expand. So x plus 1, x plus 10. We know that both are products, right? Yes or no? So it's very simple. Always remember, there are two ways of doing it, but which way you feel comfortable is totally up to you. Let me try showing you in both the ways. First way, that is a little shorter. That means I can multiply x into x gives us x squared. Again, x into 10 gives us 10x. Plus 1 into x gives us x. Plus 1 into 10 gives us 10. Gives us x squared plus 11x plus 10. This is one way to do it. The other way of doing it, like x plus 1, x plus 10. If you find it hard to understand this way, you can I can suggest you can follow this way as well. No problem. Here we have x. Take the whole thing together. X plus 10. separate by plus 1, take the whole thing again, x plus 10. Now remove the bracket, x into x, x squared plus 10x plus x plus 10, x squared plus 11x plus 10. In both the ways, the answer remains the same. There are a few sums again which I want you to practice yourself as well. Just one last sum which I will do and then I will conclude it. Okay, next we have question number 5, that is x minus 3 the whole square. So as you can see, it's already given here in the textbook as well. So I'll just try to solve and let's try to fill in the boxes. That is x minus 3 the whole square means x minus 3 into x minus 3. So they have given, like here we can do it simple way as I have done it in the earlier question. That is x squared minus 3x minus 3x plus 9. X squared minus 3x minus 3x. Minus 3 minus 3 gives us minus 6x plus 9. Now moving on to the next, we have m plus 8 the whole square. You can do it that either way, m plus 8, m plus 8. Here we have m squared plus 8m plus 8m plus 64. M squared plus 16m plus 64. Now, what I would suggest in both the cases also, as we know the formula, that is identity, that is a plus b the whole square gives us a squared plus 2ab plus b squared. You can use either of the, you can use this way or you can use that way. In this way, if we use the formula here, that is m plus 8 the whole square, we get the answer as a squared, that is m squared, plus 2ab, that is 2, we have a and b, plus b squared, we have 8 squared, m squared plus 16m plus 64. Same for this, you can use the identity, that is a minus b the whole square, that is a squared minus 2ab plus b squared. That's all for today. Thank you both boys and girls. Please make sure the sums which I haven't done, please make sure that you practice at home. If any doubts, kindly call me up to clarify doubts. Thank you, stay safe and have a good day.